Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, kth smallest element in BST. Okay, so what the problem is saying is we'll be given a BST and an integer k. We want to find out the kth smallest element in the given BST. So here is the BST and here is the value k and k is 3. Now, first of all, let's see which is the smallest element in this BST. That is 4, right? Smallest element is always going to be on the left side, right? Because you know the property of BST, like the left subtree, the elements in the left subtree are lesser than the or they are the smallest basically. Okay, you know the property, right? So this is a node, then this is the left subtree. Okay, the elements in the left subtree, they are going to be lesser than the elements in the node, and elements on the right subtree, um, they're going to be greater than the element than the node element. Okay, so the question here is to find the kth smallest. So definitely you're going to go on the you're going to find out that in the on the left side. Okay, on the left side. Okay, so here the smallest element is 4. Okay, and which is the second smallest element? That is 8. And which is the third smallest element? That is 10. Okay, and we want to return this particular element because k equal to 3, which is they're asking us to return the third smallest element. Okay, so now, so this is the ask. I hope you've got the ask. Now let's go and look the approach how to solve this problem. Okay, so we will be at the root, we'll be doing the DFS traversal. So we are going to go to the left subtree first. Okay, so here it is 8. We are going to go further left. Now we got 4. We are trying to go to the further left, but here we don't have left child, so we're going to return 0. Okay, so when we go to the right child, okay, for example, now let's say we have k equal to 3 here, right? When we go to the right child, we are going to reduce the k, because one of the we have found one of the smallest element, that is, it can be the smallest element basically. Okay, so we're going to go to reduce and we're going to check. Okay, we are going to check is k 0. Now what we are going to do, for example, for each small element, right, we are going to keep on reducing a k. Okay, we are going to keep on reducing k when k is 0, right? That means we have found our smallest, the required smallest element. Okay, we have found the required smallest element. That is, we have found our kth smallest element. So we once we come from the left, we are going to reduce our k. Okay, and we are going to check is k 0. No, it is not. K is not 0. That means we have not found our kth smallest element yet. So we are going to go to the right. Okay. Right, we again get 0. Okay. So now we are done processing 4. We are going to go back to 8. Okay. We are done processing the left child of 8. Now we'll go to the right child. Okay. Before going to the right child, we are going to reduce the size of k. We are going to reduce k, or we are going to decrement k. Okay. So k is 1. We are again going to check is k 0. No, it is not. That means we have not found our kth smallest element. So we went on the right side. Now, as per our DFS traversal, right? Again, we have come on 12 now. We're going to go to the left child of 12. Okay. Then, okay, we have come on 10 now. We will go to the left child of 10, but there's no right left child, right? So we're going to go back. We're going to return 0 here. Now, now, now when before going to the right child, right, we are going to reduce or we are going to decrement k. Okay, now we're going to check if k equal to 0, right? If k equal to 0, okay, that means we have found our kth smallest element, and hence we are going to return we are going to store this particular value in the result, and we are going to return from here. Okay, so this is the intuition behind solving the problem. I hope you have got the intuition. Just one request before going to the code to please subscribe to the channel, like the video. I think you'll understand better with the code. Okay. Okay, so first we'll implement the Java code followed by C++. Okay, so we are going to take two class variables. Let's say count equal to int count equal to, okay, let's say for now it is 0 and int result equal to -1. We'll also initialize here count equal to k. We are going to assign k to count and result -1 again. Okay, now we'll have our utils. Okay, which is going to be root. Now void utils node root. Okay, so what we're going to do, first of all, we'll go to the left subtree. right? Then we are going to reduce our count, minus minus count, as I told, as I've already explained this, right? After we come from the, or we are done processing the left, the leftmost, right? The left child or the left subtree, right? We are going to decrement. Before going to the right subtree, we are going to decrement the count. And what will be the base condition? For example, if there's no child, right? If there's no child for a particular node, if it is a leaf node and it does not have any child, so we are going to return from here. Okay, we are going to return from here. Now we're going to check here post decrementing. If it is 0, that means we have found our kth smallest element. So k result equal to root dot data, and we are going to return from here. Okay. So this is post uh, traversing the left child. Now, if there is like if the count is still not 0, right? So we want to go to the right side to find out the kth smallest element. Okay. So this is it. Let's now return the result. Let me compile this. Okay, let's submit this. Okay, the test case are passed. Thanks for watching. Please subscribe to the channel, like the video. Let's quickly see the C++ code. Okay, so here's the C++ code. So here we have our two class variables, right? And then we are initializing k and result -1. Okay, and then we are calling our util function, and finally we are returning the result. Now the util function, if you know the base condition, if there's no node, we are going to return as is. Will traverse the left child. Okay, we are going to iterate the left child. Then we are going to decrement the count. Okay, here if count is 0, then assign the node data. That is, we have found our kth smallest element. Assign that to result and just return. And then try, if the count is still not 0, go to the right side because the kth smallest element may be on the right subtree. Okay. Okay. So thanks for watching. I'll attach the code in the description section. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.